Section 4.2.7, we're going to complete parts A through H for the data below. Part A, it says by hand, we're going to draw a scatter diagram treating x as the explanatory variable and y as the response variable. So the x variables are 1, 2, 3, 5, and 6. The y variable is 3, 4, 11, 19, 23. So let's take a look at the first order pair. Well, the first order pair is going to be 1 and then 3. The second order pair is going to be 2 and then 4. The third order pair is going to be 3 and then 11. The fourth order pair is going to be 5 and then 19. And then the fifth order pair is going to be 6 and then 23. So let's go ahead and plot those points. So down here we have, we're going to go to 1 and then we're going to go up 3. So 1, 2, and 3. So there is our first point. Our next point is 2 and then 4. So we're going to go over 2 and then up 4. Okay, our next order pair is 3 and 11. So we're going to go to the right 3 and then up 11. The next order pair is 5 and then 19. So we're going to go over 5 and then we're going to go all the way up to 19. And then the last order pair is going to be 6 to the right and then it's going to go up 23. So therefore, there is our scatter diagram by hand. Next, we want to be able to find the equation of a line containing the points 1, 3, 6, and then 23. Okay, so we're going to call the first order pair x1, and then this is y1, and then we're going to call this x2, and then we're going to call this y2. So the first thing we need to do is we need to find the slope. So the slope formula, m, which is going to equal y2 minus y1 over x2 minus x1. So we know that y2 is 23. And we're going to subtract y1, which is 3. And then we're going to divide that by x2, which is 6, minus x1, which is 1. So therefore, 23 minus 3 is 20, 6 minus 1 is 5, and 20 divided by 5 is going to give us 4. So now we know that the slope is going to be 4. Okay, now we still need to find the equation of the line, so we need to use the point-slope form. Point-slope form is y minus y1, which is equal to m times x minus x1. Okay, so we have y minus y1, we can see here we label it as 3, which is equal to the slope, which is 4, times x minus x1, which is 1. Okay, now what we want to do is we want to put this in slope-intercept form. So what we want to do is we're going to distribute the 4 to both of those two terms. So we get y minus 3, which is equal to 4x minus 4. Because 4 times x is 4x, 4 times minus 1 is minus 4. And then in order to solve for y, we're going to add 3 to both sides. And so therefore y is going to equal 4x minus 1. Okay, now let's take a look at the next question. Next question says to graph the line found in part B on the scatter diagram. So let me go ahead and copy this scatter diagram. I'm going to paste it down here. Okay, and we want to be able to graph this line. Y is equal to 4x minus 1. Okay, now 4 represents the slope. And the slope is 4 over 1. And then minus 1 represents the y-intercept. Okay, and so the y-intercept is negative 1, but we want to write this as an ordered pair. So if we want to write this as an ordered pair, we're not going to call it negative 1. We're going to call it 0, negative 1, because if it was a y-intercept, that means that the x value is going to be 0 and the y value is going to be negative 1. Okay, so let's go ahead and draw this line here. So the first thing we need to do is we need to find out where is this point located. Where is 0, -1? Okay, so 0, -1 is located right here. Here's where 0, -1 is. Okay, and our slope, okay, since this is where our 0, -1 is located, now what we want to do is we want to use our slope. And our slope tells us that we're going to have to go up 4 units. So we're going to go up 4 units because it's a positive. And then it's a +1, so we're going to go to the right 1 unit. So from this point, we're going to go up 4. 1, 2, 3, 4, and then to the right 1. So there is our first order pair. And then from here, again, we're going to go up 4. 1, 2, 3, 4, and then we're going to go to the right 1 unit. And again, let's keep doing that. We're going to go up 4. 1, 2, 3, 4, and then to the right 1. Then again, we're going to go up 4. 1, 2, 3, 4, and then to the right 1. Then again, we're going to go up 4. 1, 2, 3, 4, and then to the right 1. Again, we're going to go up 4. 1, 2, 3, 4, and then to the right 1. Again, we're going to go up 4. 1, 2, 3, 4, and then to the right 1. And then again, up 1, 2, 3, 4, and then to the right 1. Okay, so what does this do? This is going to create our line. Okay, so we have a line. Okay, and let's go ahead and draw this line starting here at 0. And we can see that there is the line. Okay, so that line, okay, passes through those points. And so therefore, this line represents the equation y equals 4x minus 1. So as you can see here with A, B, and C, this is how you're going to do that by hand. Now, if we want to do this with StatCrunch, I'm going to pull up the data here. I'm going to open it up in StatCrunch. Okay, and then what I want to do is I want to be able to then take this data and I want to create a scatter plot. So down here in graph, I'm going to go all the way down to scatter plot. I'm going to make sure that my x variable is the x column. I'm going to make sure my y variable is the y column. Okay, and then what I want to do is I then want to put in a scatter plot, which is going to do already. And then I want to add the equation that I just got, which is 4x minus 1. So it says here, overlay polynomial order. So we want a 1-degree polynomial, okay? And here, we don't want the best fit. We're going to put in the equation that we just created. Now, C0 represents the y-intercept. And the y-intercept was -1 or -1. And then the C1 represents the slope, which was 4. So we're going to go ahead and put 4 in there. Okay? So this is the same thing as saying y is equal to -1 plus 4x, or the same thing that we got with our equation, which is y is equal to 4x minus 1. And now let's go ahead and compute. So when we compute, now we can see the scatter plot, and it also includes the line that we just created here. So that is using technology, right, to confirm our results that we just did by hand. Okay, now in part D, it says by hand, we want to determine the least squares regression line. Now what we want to do is we want to first find the correlation coefficient R, and the formula here below can be used to find the sample correlation coefficient, where x bar is the sample mean of the explanatory variable, S subscript x is the standard deviation of the explanatory variable, y bar is the sample mean of the response variable, and S subscript y is the sample standard deviation of the response variable, and n is the sample size. Now, we know that the sample size n means that we have 5 ordered pairs, But what we're going to do is we're going to focus on the numerator right now. We want to find the sum of multiplying these two formulas together. So there's a few little pieces of work that we need to do. Now, we're going to have to calculate the mean of the x variable and the y variable, and we also have to calculate the sample standard deviation of the x variable and y variable. And we're going to round that to 3 decimal places. So going back to StatCrunch, okay, what we want to do is we want to find the mean of x and the sample standard deviation of this column. We want to find the mean of y and the sample standard deviation of that. So we're going to go ahead and select Stat, Summary Stats. We're going to go to Columns. Okay, so we're going to select x. We're going to select y. Okay, we want to find the mean, and we also want to find the standard deviation. Okay, so we're going to go ahead and select Compute. And now I'm going to go ahead and copy this information. Okay, so let's take a look at this information that we have here. Okay, so what we have found? Well, we have found that the sample mean for the x is equal to 3.4. And the sample mean for y is equal to 12. So we can see that here and here. Okay, and then we're going to calculate the sample standard deviation. We're rounding out to 3 decimal places, so that's going to be 2.074. And then the sample standard deviation for y is rounded to 3 decimal places, which is 8.888. Okay, so why do we need this information? Well, we need it in order to figure out this formula. We need to take the value of x and then subtract the sample mean, which is 3.4, and divide it by the sample standard deviation. So we're going to create a table here. Okay, so if we notice here, we have the values of x. X goes from 1, 2, 3, 5, and 6. So that represents x subscript I. The sample mean is going to be 3.4, and we're dividing it by the standard deviation of x, which is 2.74. Okay, so let's take a look here. So for this first column here, okay, we have the formula. We're going to take the value of x, which is 1, which is here, x subscript I. We're going to subtract the mean, which is 3.4, and divide it by the standard deviation of 2.074. And that gives us negative 1.157184. Okay, let's do the same thing. So now what's going to happen, okay, and I'll go ahead and use a highlighter here. Okay, we know that the value of x is 1, and then we'll subtract the sample mean and the sample standard deviation. Okay, now let's take a look at the next one. So what do we do here? Well, again, we're going to take the value of x, which is 2. So now it's going to be 2 minus the sample mean of 3.4 divided by 2.074, which gives us negative 0.675024. Okay, and then what we're going to do is we're going to again use x here. Okay, so we got x, which is 3 minus 3.4 over 2.074, which gives us negative 0.192864. Then we do the same thing. Now we're going to use 5. 5 minus the sample mean over the sample standard deviation gives us this following value. And then we do the same thing here with 6. We get 6 minus 3.4 over 2.074. So now we have these values. Okay, and now what we're going to do is now we're going to take a look at, again, let's go ahead and just highlight this. So we have 5, there's our value of x, and there's 6. Okay, all right, so now what we're going to do is now we're going to look at the value of y, and then we're going to subtract the y mean and the sample standard deviation. So let's take a look at that formula here. So we're going to take the value of 3, and that's for the y, and we're going to subtract the sample mean, which is 12, divided by the sample standard deviation of y, which is 8.888. Okay, likewise, we're going to take 4. So now 4 is the next y value. So now that becomes 4 minus the mean of the y values divided by the standard deviation of the y values. And next, we're going to take the value of 11. So this is going to be 11 minus the mean of the y values over the standard deviation. And then again, we're going to take the next y value, which is 19. So 19 minus 12 over 8.88. And then the last one, we know the value of y is going to be 23. So we take 23, we subtract 12, divide that by 8.888, and therefore there's the value. Okay, now we're not completely done yet, because now what we want to do is we're going to take these two values here, and we're going to multiply them together. So we're going to take these two values, we're going to multiply them together. Here's these two values, we're going to multiply them together to make the last column. Okay, so let's take a look here. So here we take, if you notice here, we're going to take this now value of negative 1.157184. We're multiplying it by negative 1.012601 to get this new value. Okay, and then we're going to do the same thing. We're going to take negative 0.675024, multiply that to get that value. Same thing here, we're going to take those two numbers. Same thing here, and the same thing here. Okay. Now, again, we've multiplied these two values to get this new value. Okay, so you can see here that this represents the last column. And what we want to do is, here we're going to take these numbers, these 5 numbers, and we want to find the sum of those numbers. Okay, so what we're going to do is we want to find the sum of that column. This means the sum of this entire column, which means that we're going to add all of these values here to get this last value. So we're adding all these values in that last column to get 3.960135. And therefore, this is the number that we want to get for this numerator. So this entire numerator is going to represent this number here. Okay, so now that we found this sum, okay, we can see that this is the number that's going to be in the numerator. So if you can see here, in step number 1, we're going to take r, and r is going to equal the numerator, which is 3.960135. And we're going to divide that by the value of n. Well, the number of ordered pairs that we have was 5. So that's going to be 5 minus 1. And so what do we get for r? When we calculate this, we get 0.990034. Okay. And now in step number 2, b subscript 1 represents our slope. And so in order to find b subscript 1, we need to take the value of r, which is 0.990034, and then we're going to multiply it by the standard deviation of y, which we found earlier to be 8.888, and then we're going to divide that by the standard deviation of x, and we found that to be 2.074. And so therefore, we're going to get the slope to be the following number. It's going to be 4.24730, and we're going to round that to 3 decimal places, which is 4.243. 3. Okay, and now in part 3, now we want to be able to find the y-intercept. So in order to find the y-intercept, we need to take the sample mean for the y value, and we know that that was 12, minus, we know that the y-intercept, okay, now the, the slope, now we're going to use this value, which is 4.2422730, not the rounded version when you're putting it into the formula. And you're going to multiply it by the sample mean of x, which is 3.4. And so therefore, this is going to give us the intercept to be negative 2.42582. And so now, when we round this to 3 decimal places, we're going to get negative 2.425. And so now, over here, we can figure out what this equation is going to be. So the equation is going to be y hat. We know that b1, we saw it rounded to 3 decimal places, is 4.243x. And then we're going to add the y-intercept, which is minus 2.425. So there is our equation. Okay, now in step number E here, it says we want to be able to graph the least squares regression line on the scatter diagram. So we're going to take this line and we're going to graph it on the scatter plot. So let's go back to StatCrunch, okay? And we're going to go ahead and select graph and go down to scatter plot. Okay, we know that our x variable is in the x. We know our y variable is the y. And then we're going to come down here and look at the overlay polynomial order. So we're going to select 1 for the degree of 1. And then we're going to put in the value of the y-intercept and the slope. Now, C0 represents the y-intercept. And what we got over here is negative 2.425. And then we can see that C1 is the same thing as B1, which is the slope, which is 4.243. So 4.243. Okay. And then we're going to go ahead and select compute. And so therefore now this is the graph of our regression line that we have just found. Okay. So therefore there is our least squares regression line, okay, on our scatter plot. So again, recall that this line represents the equation 4.243x minus 2.425. Okay, now in part F, what we want to be able to do is we want to compute the sum of the squared residuals for the line found in part B. Now, the residual is given by the formula. The residual is equal to the observed y, which is the y in this column. These y's, 3, 4, 11, 19, and 23, represent the observed y. And the predicted y is taking the value of x and substitute it into this formula to find out what the observed y is going to be. So you see this formula, y is equal to 4x minus 1. We're going to plug in each value of x and find out what that predicted value is going to be. So let's go ahead and do that. So if we take 4, multiply that by 1, which is 4 minus 1 gives us 3. So the predicted y value is going to be 3. Same thing here, if we plug in 2 in for x, 4 times 2 is 8, minus 1 is equal to 7. So the predicted value of y is going to be 7. Here we take 4 times 3, which is the x value, which is 12 minus 1, which gives us 11. And then 4 times 5, which is 20 minus 1, gives us 19. And then 4 times 6, which is 24, minus 1 gives 23. So now we know that here's the predicted value, and then here is the observed value. So we're going to take the observed value and then subtract what we got here. So that's the next column. So if you look here, we take 3 and subtract 3, which gives us 0. Here we're going to take the observed value, which is 4, and subtract 7. So 4 minus 7 gives us negative 3. Next, we're going to take the observed and subtract the predicted. 11 minus 11 is equal to 0. Likewise here, we're going to take the observed and subtract the predicted value of 19. 19 minus 19 is equal to 0. And then here, the observed, which is 23, subtract 23, which gives us 0. Okay. Now that we have these values, now we need to square that. So we're going to take 0 and then square it, which gives us 0. We took this 0 here. Okay. Likewise, we're going to take negative 3 and square it to give us positive 9. Again, we're going to take 0, square it to give us 0. We're going to take 0 again and square it to give us 0. And we're going to take 0 again, square it to give us another 0. Okay? So now what we want to do is we want to find the sum of the squared residuals. Meaning now we're going to add this column together. We're going to take 0 plus 9 plus 0 plus 0 plus 0. And when we add it together, we get 9. So the sum of the squared residuals for this equation is equal to 9. So that's what we get for part F. Okay, next. Now what we want to do is we want to compute the sum of the squared residuals for the least squares regression line that we found in part D. So again, the residual is given by the formula, the observed y minus the predicted y. And recall that the line that we found in part B was equal to 4.243x minus 2.425. So we're going to complete the table below for the predicted values of y. So again, the observed values of y are 3, 4, 11, 19, 23. In order to find the predicted values, we're going to substitute the value of x into this equation. So just like we did in the previous step, we take 4.243, multiply it by 1, and subtract 2.425 to get 1.818. Do the same thing. 4.243, multiply it by the value of x, which is 2. Subtract that to give us 6.061. Same thing, multiply that by 3 to give us 10.304. Likewise, substitute 5 into the equation, and then getting 18.79. And then likewise, substituting an x into this equation to get 23.033. And now we're going to take the observed value and subtract the predicted value. So we're going to take 3 and subtract 1.818 to get 1.8182. We're going to take the value of 4, subtract the predicted value to get negative 2.061. Again, we're going to take 11, subtract 10.304 to get 0.696. And then again, 19 minus 18.79 to get 0.210. And then again, the observed minus the predicted to get that value. Now we're going to take each one of these values and then square it. So we're going to take 1.182 squared to get this value here. Negative 2.061 squared to get this value here. Same thing here, 0.696 squared to give us 0.484. 0.210 squared to give us 0.044. And then likewise, negative 0.033 squared, which gives us the following here. Okay, so now what we want to do is we want to find the sum of the squared residuals in this column. So when we add up all these numbers, we get the value of 6.174. Okay, now the last part, it says comment on the fit of the line found in part B versus the least squares regression line found in part D. Now we want to consider these two diagrams. We're going to compare the number of points that each line passes through. The line with the least sum of square residuals is the better fit. Compare the values to determine which line best fits the data. Okay, so if you take a look at part B, which is that, it goes through 1, 2, 3, 4 points. In part D, this goes through 1. Okay, so we can see here that the line in part B passes through the most points. The line in part D minimizes the sum of the squared residuals because we got 6.174. Therefore, this is the line of best fit. because it is the best fitting line for that graph.